Today we will be in Chapter 9, Section 1, Solving Systems of Equations Graphically. Our three topic objectives for today are to determine if an ordered pair is a solution to a system of equations, to determine if a system of equations is consistent, inconsistent, or dependent, and to solve a system of equations graphically. Today we will be in Chapter 9, Section 1, Solving Systems of Linear Equations Graphically. But first, let's define what a system of linear equations is. A system of linear equations is a group of linear equations that we seek a common solution for. An example of a system of linear equations is y equals x plus 5 and y equals 2x plus 4. We use the squiggly sign or the squiggly bar out front in order to group these together to show that we are dealing with a set of linear equations. Here's another example. We have y equals 3x plus 6, y equals 4x minus 7, and y equals 15x plus 20. Systems of linear equations can have two equations, they can have three equations. Theoretically, they can have as many equations as you'd like. And for this course, you're going to deal with two equations, so you're going to be dealing with ones that look like this first example. But I did want you to know you can have systems with more equations, and that is okay. So, what are we going to do with these? What we're going to do is we're going to try and solve these. Before, when we were solving equations, we had one equation, so we had to find one solution. Well, in this case, we have two equations, and we're going to try and find a solution that works for both equations. So, one of the types of problems you're going to have is going to be determining if an ordered pair is a solution. So this is one of the types of problems you're going to have, and what they'll do is they're going to give you a system of linear equations. So for this one we have y equals 2x minus 8, and then we have 2x plus y equals 4. So there's our system of equations. They will also give you then a point that they want to know whether or not that is a solution. So we have the point 1, negative 6. So what you're going to do for these problems is you're just going to take whatever point they give you and you're going to plug it into both equations and see if it's a valid solution. So the first thing you have to remember is that our points are given in x, y form, and then you're going to look at each of the equations separately. So we have the y equals 2x minus 8. So our x value is going to be 1 and our y value is going to be negative 6. So we're just going to plug those in. And now we solve and see if we get a valid statement. 2 minus 8. Negative 6 equals negative 6. That's a true statement, so that's a good thing. So it worked for that equation. But we have another equation we have to plug it into to see if it works. So let's do that. We have 2x plus y equals 4. So again, our x's are 1. And our y's are negative 6. So you get 2 minus 6 equals negative 4. Negative 4 equals negative 4. That was true. So it gets a check mark. So that means that this is a valid solution for the equation. So that one's good. I'll write true over here. It has to be true for both equations in order for it to be a solution. Let's do another one. B. We have 3, negative 2. You're dealing with the same system of equations, so we have the same equations, except now our y is -2 and our x is 3. So you should get -2 equals -2, so that's a good thing. Then we have our second equation. Sorry, I was reading my notes trying to make sure I did this right. So that one also worked out. So this is also a true one. Sorry, in my notes I must have worked the first problem wrong. 2x oh, excuse me. Up here, I added a -4 over here. That's supposed to be a +4. Right there, very important to keep track of your negatives. So right here we have a -4 equals a +4, and so that is not true. Sorry about that. Luckily we caught it. So because -4 does not equal +4, that's not true for the second equation, so that means this solution does not work. But in our second example, that point worked for both of our equations, so that means it is a solution. Alright, let's do another example, and hopefully this time I can keep my negatives in check. Scroll up to the top. Okay, here's another example. Again, we're just going to determine if a order pair is a solution. So we have x plus 4y equals 8, and we have y equals 3x minus 11. So the first point is going to be 8, 0. So our first equation is the x plus 4y equals 8. Wherever the x is, we're going to have an 8, and wherever the y is, we're going to have 0. So we have 8 plus 0 equals 8. 8 equals 8. It's good for the first one. For the second one, we have y equals 3x minus 11. 0 goes in for the y. 8 goes in for the x. So you get 0 equals 24 minus 11. You get 0 equals 13. Is that true? Does 0 equal 13? No, that's not true. So this is false. This is not a solution for that system of equations. Alright, let's try another point. Let's try 4, 1. These are what I like to call plug and chug problems. You're just plugging in the values that they give you into the problems that they give you. You should get 8 equals 8 on that first equation. And you should get 1 equals 1 on the second equation. So since we got 2 true statements, that means that this is a solution for that system of equations. So hopefully those are not too difficult. Those are just plug and chug problems. They give you the problem, they're going to give you the point, you just plug them in and you see which ones hold true. Obviously, in our first example, you do need to be careful of keeping track of your negatives because you can make a simple mistake like I did and then get it wrong. Now, when you're dealing with systems of equations, there are three different types of solutions that you can get. And so I want to show you all three of those. Three types of systems of equations. Okay, the first type, I'm going to draw a little graph for each of these. Okay, the first type is just going to be, here's your line, and here's another line. So they intersect at that one point, and so that one point is your solution. Because that's the only point that those two lines have anything in common, is that one point. So this type of system of equations has only one solution. Those are the ones we've been dealing with the above examples where we're finding whether or not that point holds for that equation. These are called consistent. These are consistent systems of equations. Sometimes you'll see me abbreviate them with a capital C. So if they only have one point, one solution, they're called consistent. So if they have one point, then you can maybe guess that another type of system of equations is going to have 0 points. And those are going to look like this. So they're parallel lines. Parallel lines do not intersect. So these has no solutions because they're never going to intersect. And these are called inconsistent. Sometimes I will abbreviate them just with a capital I. So these are parallel lines. They're never ever going to cross, so you're never going to have a solution for these. Okay, so we've had one that has one solution, one that has no solutions. So our last type of system of equations I'm going to get out some markers so I can show you. We have the red line, and then on top of that, directly on top of it, you're going to have the blue line. So if the blue line lies directly on top of the red line, how many solutions do you think that there are? They are going to have infinitely many solutions. These are basically the same line, just on top of each other. These are called dependent. And I will sometimes abbreviate it with just a capital D. So those are the three types of systems of equations. You can have consistent ones, which have only one solution. You can have inconsistent ones, which have no solutions, and then you can have dependent ones, which have infinitely many solutions. I'll give you a second to write those down before we move on. Part of your homework will be determining whether a system of equations is consistent, inconsistent, or dependent. And it's actually quite simple. I'm going to give you a couple of little hints and then we're going to work one. Okay, I'm going to move on. So, if a problem asks to determine if a system of equations is consistent, inconsistent, or dependent. So some of your problems are going to be that. So here is my little helpful hint. You want to find the slope of your two lines if the slope, or the slopes, excuse me, are not the same, then your system is consistent. So if you find the slope of your two lines and they are not the same, then your system is automatically consistent. And that's because if they're not the same, that means they're going to intersect, and that means that you're going to be consistent. Okay, so if the slopes are the same, you need to find the y-intercept. And then from here, if the y-intercepts are the same, then your system is dependent. If your y-intercepts are not the same, then your system is inconsistent. Maybe looking at all this in words doesn't make as much sense, but let me draw those three graphs again real quick, and hopefully it will. This one's going to be consistent, inconsistent, and dependent. Okay, so your consistent graph, you have your two lines, and they just intersect at that one point. So these have slopes that are different, and they intersect just at that one point. Your inconsistent graphs are your parallel lines. If they're parallel, that means they have the same slope. And so right there, that differentiates between those two. And these aren't ever going to intersect. And if you look, this one has a y-intercept up here, and this one has a y-intercept down here. So consistent ones have different slopes. Inconsistent ones have the same slope, different y-intercepts. Sorry, trying to get that all on the page for you. And then your dependent ones, let me get out my markers. That's your line with the other line on top. So if the line is directly on top, then that means it's going to have the same slope. But unlike parallel lines over here, like our inconsistent ones, these are going to have the same y-intercept. So when you're looking at a system of equations, you have to find the slopes, and eventually you might have to find the y-intercepts. If you find the slopes of your system and they are different, you know it's going to be a consistent system. If you find the slope and it's the same, you know it's going to be either an inconsistent or it's going to be a dependent. So then you have to look at your y-intercepts. If they have different y-intercepts, it's inconsistent. If it's the same y-intercepts, it's dependent. We're going to work one of these so you can see what I'm talking about. Okay, I'm going to move on so I can work one of these for you. Alright, let's do an example. We have 2x plus 4y equals a negative 15. Negative 8y equals 4x minus 12. So for this problem, it wants to know whether it's consistent, inconsistent, or dependent. That's all it wants to know. So what do we do first? We need to write this in slope-intercept form. So we need to write equations in slope-intercept form and compare slopes. Okay, so let's write the first one. We have 2x plus 4y equals negative 15. Remember, slope-intercept form is y equals mx plus b. So we're just going to solve for our y. So subtract our 2x from both sides and divide everything by 4. And then remember, our m is our slope, so in this case our m is negative 1/2. And just because we might need to know this, what is our y-intercept then in this case? That's our b. So it's just minus 15 over 4. So our y-intercept is 0, negative 15 over 4. Because if we find that our slopes are the same, then we're going to have to know this. So that's just kind of an extra little step. Let's write our second equation in the y equals mx plus b form. Luckily y is almost already all by itself, so we just have to divide both sides by the negative 8. So we get y equals negative 1/2 x plus 3 over 2. So our slope in our second one is also a negative 1/2. So our slopes are the same. So that means it's not going to be consistent because our slopes have to be different to be a consistent one. So our slopes are the same. So it's either inconsistent or dependent. So we have to know what our y-intercepts are. Our y-intercept on our first one is 0, negative 15 over 4. And our y-intercept in the second one is 0, 3 over 2. Are those the same? No. Since these are not the same, that means we are inconsistent. Let's do one more where we're determining if it's consistent or inconsistent or dependent. Example. We have y equals x minus 2, y equals negative x minus 8. So is this consistent, inconsistent, or dependent? It's already written in the y equals mx plus b, so we just need to know what our slopes are. So for the y equals x minus 2, our slope in this case is 1. And for the y equals negative x minus 8, our slope in this case is a negative 1. Those are not the same slope, and if they're not the same, we only have one option, and that means it is consistent. So if the slopes aren't the same, it's actually really nice, and it should be a relatively quick problem for you. Okay, so now it's time to actually solve a system of equations graphically. We've been determining if solutions worked, and we've been determining if a system of equations is consistent, inconsistent, or dependent, but now we actually need to graph these and be able to solve them via graphing. So the two steps for doing this is to first, you're going to graph each equation that's in your system, and then you're going to determine the point or points of intersection. So for our first example, we have the system of 2x plus y equals 11 and x plus 3y equals 18. Back in chapter 4, you learned a lot of different ways to graph your lines, and so however you want to graph them, that is up to you. If you want to solve them for y equals mx plus b, and then use your slope and your y-intercept, that is fine. I am going to just use the x-intercept and the y-intercept for each of my equations and just plot those 2 points and then connect them. So in order to do that, I just need to look at each equation separately. To find my y-intercept, my x is going to equal 0. So when x equals 0, we get 2 times 0 plus y equals 11. 0 plus y equals 11, so y equals 11. So we have the point in 0, 11. And for our second point, we will let y equal 0. So that'll be 2x plus 0 equals 11. So 2x equals 11, x equals 11 over 2. So my second point will be 11 over 2, comma 0. Okay, I'm going to go ahead and graph this line so you can see it. And I'm going to designate this as my red line, because I'm going to graph this on graph paper, and I'm going to use different lines to try and make it easier. So my first point is 0, 11. So that means I have to go, I don't go left or right in, I go up 11. 1, 2, 3, 4, 5, 8, 11. My other point was 11 over 2, which is 5.5, comma 0. So 1, 2, 3, 4, 5.5. Right there. And then I need to connect those two lines. Sorry if my lines are a little crooked. Even with a straight line, a straight edge, I'm very good at making crooked lines. So there's my first line. Oh, sorry, I ran off the paper. There's my first line. But that's only half of our problem, because when you're dealing with systems of equations, you're going to have 2 equations. So now it's time to look at our second one, which is x plus 3y equals 18. So I'm going to have x equals 0. So that's going to leave me with 3y equals 18. Y equals 6. So my first point will be 0, 6. I'll go ahead and box this. This will be my blue line. Okay, next I want to do y equals 0. So we have the x plus 3y equals 18. So that'd be x plus 3 times 0 equals 18. That will give us x equals 18. So our second point will be 18, comma 0. Okay. So here's my graph paper. First point was 0, 6. 6 right here. And our second one was 18, 0. So there's 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. All the way out there. Connect up those 2 points. Oops. See, told you I'd be able to make a crooked line. Alright, so there's our graph, and if my lines were straight, which they are not, but if they were, you would see, I mean right here's where my intersection is. My intersection really should be over here, but I did a really crooked line on my blue line. But when you're using the program, when you're using Course Compass, all your lines will intersect very nicely on a nice line. So then you can determine that your ordered pair, or your solution for this problem, is 1, 2, 3, comma 1, 2, 3, 4, 5. So your solution to this problem would be 3, comma 5. And you know that because your two lines intersect at 3, comma 5. Again, when you're doing it on paper, it might not be super clear cut like that, but when you're doing it on the computer, you'll know exactly where they intersect. And so if you have two lines that intersect and there's only one solution, that means that this is a consistent system of equations. Alright, let's do another one. Sorry, I'm trying to find the best way to do this. Here we go. Alright. So another example. We have 2x plus y equals 3. 4x plus 2y equals 12. So there's our new system. Again, the first step is just to graph them. So I'm again going to use my intercepts because I think it's a lot quicker and easier. But whatever method you like to use to graph your lines, you go for it. Lost one of my markers. Okay, if I let x equal 0, then y is going to equal 3 on that first one. If I let y equal 0, 2x is 3. So x equals 3 over 2. 3 over 2, comma 0. I'm showing less work because hopefully after chapter 4 you know how to find these, or you know how to graph these. So I'm going to go ahead and do this one. 0, 3. 1, 2, 3. And then 3 over 2 is 1.5. There. This paper is a little bit thicker, so maybe I can draw a straighter line. So there's my red line, there's my first line. So now let's look at the second equation, the 4x plus 2y equals 12. Let x equal 0. That'll leave me with 2y equals 12. So y would be 6. So that would be 0, 6 would be my first point on my blue line. And then if I let y equals 0, I would have 4x equals 12, x equals 3. So I'd have 3, 0 as my second point. So then I just need to graph those. So my first one was 6, 0, so 1, 2, 3, 4, 5, 6. And my next one was 3, 0, so 1, 2, 3. Be a little bit more careful on this one. Okay. And I even graphed them well enough that hopefully you can see that these two lines are parallel. So these two are never going to cross. So that means these are inconsistent lines. And that it means how many solutions do we have? If they never cross, we have no solutions. Okay. So if we've done a consistent one and we've done an inconsistent one, we might as well go ahead and do a dependent one so you can see what those look like. So I'm going to take this away. Third and final example of this. We have x minus 1/2 y equals 2, and we have y equals 2x minus 4. Again, you just need to solve for your you don't need to solve, you need to graph each of your lines separately. So again, I'm going to just use my x and y intercepts. So if x is 0, I have negative 1/2 y equals 2, so y equals a negative 4. So I get 0, negative 4 as a point. And then if y equals 0, then I'm just left with x equals 2. So my point is 2, 0. So let's graph that. Sorry, my dot split through from the other page, but we have 1, 2, 3, 4. And our other point was 2, 0, just right there. So there's my red line. Now I need to determine the solution for my blue line. So my second equation was the y equals 2x minus 4. So if I'm letting x equal 0, then that's going to leave me with a y equals a negative 4. So my point is 0, negative 4 for my blue. which if you notice is the same point as my red one. And then if I let my y equal 0, it's going to be 0 equals 2x minus 4. So I have to add my 4 over, divide by 2. So I get 2 for my x. So I get 2 comma 0. So if you are graphing with your x and y intercepts for your dependent graphs, you're going to get the same answer. So for my graph, this would be my point, and this would be my point, and then my blue line lies directly on top of my red line. So this is a dependent system, and when they're dependent, that means there's infinitely many solutions. So let's go open up your homework and I'll show you how to do this on the Course Compass site. Okay, so for 9.1, your homework is only 9 problems, and actually we've worked examples of all of these already in your notes, so hopefully there's no surprises to you. The first set of problems are going to ask you to determine which, if any, of the following ordered pairs satisfy the system of linear equations. And so these are just plug and chug. You're going to plug in each of these ordered pairs and determine if they work or if they don't work. And if they work, then you're going to type them in. And if none of them work, then you're just going to click none of them work. Then if you go further on, you're going to do some graphing. So I wanted to do number 7 with you, just so you can see how to use the graphing on here with two equations. So I'm going to leave both windows up so you can kind of see my work and see how we're going to do this. So I'm going to do this one at a time. I'm going to deal with one equation at a time. X minus y equals a negative 4, and x plus y equals a positive 12. So there's our system. So I'm only going to deal with the top one first. So that's our x minus y equals a negative 4. So when x equals 0, that's going to leave us with negative y equals a negative 4. Multiply both sides by a negative 1, and we get y equals 4. So that ordered pair will be 0, 4. Now if I let y equals 0, then that's going to leave me with x equals a negative 4. So my second point will be negative 4, 0. So those are my 2 points for the top line. So I'm going to go ahead and graph that. On your Course Compass site, remember you can make your graph bigger by clicking this magnifying glass. And then you have to click your line tool, which is right over here. You click that, and my first point was 0, 4. So 0 and then up 4. Notice in the upper right hand corner of this magnified box, it tells you what your point is to make sure you're on the right point. So I put that there, and then my second one was negative 4, 0. Put that. So that's my first line. Let's figure out what my second line is going to be. My second line was the x plus y equals 12. So if I let x equal 0, that's going to give me y equals 12. So that's 0, 12. If I let my y equal 0, then that's going to leave me with x equals 12. Well, those were nice. There was no math really involved in those. So 0, 12, and 12, 0. That's what I need to graph for my second line. So again, I need to select my line tool, and then I need to do 0, 12, and 12, 0. once you have those graphed, make sure you click Save. And then check answer. Well done, we got it. Now it says, what is the solution to the system of equations? So we get three choices. We get the solution is, and we can type an ordered pair, or we can say it has infinitely many solutions, or it has no solutions. This was a consistent system of equations, so that means there is one answer. So again, if you magnify, hopefully you can look at the graph and be able to determine what that point is. We know it goes up to 8, and it looks like it goes over to 4. So that means our point would be 4, 8. So let's type that in an ordered pair. Don't forget your parentheses. 4, 8. Close your parentheses. Let's check your answer. We did it right. So that's what you're going to be doing whenever you graph your equations and you find your ordered pairs. You've done an example of each type of homework problem already in your notes, so I hope this is straightforward. Good luck on your homework and good luck on your quizzes.